This is Steve N4LQ. We're going to run some tests on an end-fed half-wave 20-meter antenna, and I'm going to try to demonstrate the current on the shield of the coax as compared to the antenna. I will try to talk slowly for my friends in Europe and other parts of the world who would like to know what happened also. So here we have the transceiver and a low power watt meter, so I can set this accurately at 5 watts. It is setting on a wooden table. We are running on battery power, no ground connection, and the coax goes up to the top of an 8-foot wooden post and across the yard. And the feed point is approximately 35 feet away. And here we have the My Antenna's 8010 end-fed half-wave transformer, and about 32 feet of antenna wire. And I did test this, and it is resonant at 14 megahertz. The SWR is about 1.5 to 1 because it is so low to the ground. So at the lowest point, it's about 6 feet over there at the end. So what we're going to do is fire this up and run 5 watts into it, and we're going to measure the feed line current all the way along the feed line, and we're going to check the antenna current and compare the two. We're running 5 watts out according to the meter. Reflected power, flipping this switch shows it is very low. There's our field strength for what that's worth. And now we're going to measure the current at the rig with our current meter. And here we are, measuring 30 milliamps. As we go away from the rig, I'll go up to 35. And then we up to 40. Back down to 30. Alright, so I've got to unclamp here. Stand by. Get it down here to where I can reach it and see it. We're at 35. We're at 20. And about 15 right here. And we're 20 feet away from the transformer. Got to unclamp again. This right here is about the quarter wave point from the transformer. Zero. We're about 10 feet away from the transformer. 15. At 30 milliamps at about 3 feet away. And now we are at the transformer, and we're showing 20 milliamps. Stand by again. Alright, we're on the antenna. We're showing 30 milliamps at the transformer. And now we're pegging out. So we switch scales, and now we're on the 300 milliamp range. And as we go up toward the center of the antenna, which is about right here, we're showing 60 on the meter, and when you interpret this scale, it's 180 mils, and then as we approach the end, it goes down, and here at the end, we're showing almost zero. Very low current at the end. So 180 milliamps was our maximum current, and that was at the center of the antenna. Check our scale here. 300 milliamp range, we were reading 60, and that is 180 milliamps. So it was averaging about 20 or 25 milliamps on the coax, and on the ends it was very low. On the far end it was almost zero. And one more thing I want to look at is the field strength. Now we're at the transceiver. As we get away from it, it drops to nothing. Now we're under the coax. We're walking toward the transformer. Ooh. And we're pegged out, so we got to back it down. And now we're walking toward the middle of the antenna. This is interesting. The field strength is down right there is the middle. It goes down to zero at the middle of the antenna. And then up here at the far end, it's pegged out again. Back it down. So, interesting. It appears that the field strength reads the highest at the far end and the lowest in the center. Back to the center again. Back toward the transformer. I'm directly under the antenna. Yeah, well, I tried to keep it the same height or distance away from the antenna. So there you go. Now for our next test, we're going to ground the radio to this heavy ground wire, which goes to an 8-foot ground rod and to this fence. And I've got two ground wires coming off the rig, and they go to the fence, and they go to the 8-gauge solid wire and over to the ground rod. Also, it's grounded to some chicken wire that is on the ground. And so, key the rig, 5 watts, check power. Alright, we're going to check the current at the rig. Okay, reading 90, 80, about 75 actually, milliamps. And let's see, we get away from the rig a little ways and it's back down to 35. So right at the rig we do have some current. I'm going to snap this. Now we'll go up to the horizontal coax. zero current here, about 10. It's down to 0. And we're about 25 feet from the transformer. The sun is rather bright. Yeah, we've got 0 current here. So let me unsnap and move it. We're at the junction. We're 20 feet away. Reading about 20. Now we're up to 40. And back up to 50 milliamps. And then we are here at the transformer now, reading 35 milliamps. All right, let me unsnap and go to the antenna. All right, and we're moving away from the transformer. We're pegging out here. We're switching to the 300 milliamp range. And now, right there is the, let's see. All right, trying to find the center, and that's 50. 50 milliamps. Getting away from it. So we've lost 10 milliamps. Let's go out to the far end. I didn't mean to say 10 milliamps, almost 0 here. Since we're on the 100 milliamp range, we're actually needing to convert. So let's go back to our chart. And let's see, our chart shows 100 milliamp range, 50. On the 300 milliamp range is 150. So we lost 30. We went from 180 down to 30 milliamps because it's grounded. All right. And let's see, field strength. Not seeing much of anything here at the rig. It kind of makes sense. And go up here to the coax. Not seeing too much here at all. Very little field strength. And we're starting to see some here on the antenna. And again, as we get to the middle, it goes to 0 and then starts back up again. And at the end, it is at maximum. All right. So there you go, for what that's worth. For our next experiment, we have installed a RF line choke, at the transformer, and a counterpoist of about 4 feet long. And measuring the current on the coax, there's nothing here. Unsnap it. Okay. They're showing about 15 milliamps right there. Getting near the choke. We've got 10 milliamps, and right here at the choke, 10 milliamps. Going to the other side now. By the way, we still have the ground connected at the rig. Okay, here we go. Over to the middle, change scales, and we're up to 60. All right, right there is our max. Back to 60 again, like it was at the beginning. Let's go out to the end. And we're down very low, about 5 right here. Maybe just a tad more than we did before. Okay. So now we've got more information showing that a line choke and a counterpoise helps isolate the feed line, which is what it's supposed to do. We'll see what happens when I take the counterpoise loose. No counterpoise. We'll check our SWR here in a minute. Oh, this is terrible. Almost no current. Almost no current on the antenna. That really wrecked it. Can't do that. Gotta have the counterpoise or the coax. Either one. Let's see what it did to our SWR over here. Yeah, it's up a little bit. Not a lot, but a little bit. So, unkey it. So where did all the power go? Gotta have that counterpoise. One more thing I can check is the current on the counterpoise. Let's try that. I'll hook it back up to our transformer, and let's just snap this thing right on here. Okay, now we're back to the 100 milliamp scale. We got 20, 10, and it's very little current. 15. And the most I see is 20 right up at the transformer. Pretty insignificant. Okay, that's that. One more test. Now we have no counterpoise except for the shield of the coax, and we have the RF choke about 6 feet away from the transformer. So in effect, it's a 6-foot counterpoised using the shield of the coax. And let's fire the rig up here. And set our at 5 watts. And let's see here. Let's check our current on the coax. Whoops. Yeah, there's none there. And we are sliding down toward the choke, and it's still almost 0. And we're at the choke, and we have nothing. All right, let's go to the other side of the choke. or actually looking at the current on the counterpoise. And they're just right at the transformer. I'm showing 20, but as you go away from it toward the RF choke, it goes down to 5. So proving counterpoise don't have much current. Now let's move it to the antenna. Pardon my dogs. Let's go to the 300 milliamp scale. Slide down toward the center. And all right, we're back to about 55. That's about the highest that I can get it. Well, 58. Virtually the same. You know, let's go out toward the end. And it's the same as before with the counterpoise. So I would say right there is maximum. It's about 58. Now, could be an error somewhere else, but I think I'm going to have to give the choke at the transformer with a short counterpoise the thumbs up. The thing I've done is remove the ground from the rig, and just out of curiosity, let's see what it is on the coax. Still got the choke, 100 milliamp scale. That hasn't changed. There's just nothing. Just nothing there. Let me run over here to the actual antenna and snap her on here. Go to the 300 milliamp scale. Yeah, we've lost a little bit. Down to 50. Interesting. Okay, again, it helps to have that counterpoise on there. And I guess we can take the counterpoise and just for kicks, clip it on here and see if that changed our meter any. It went, yeah, it's exactly 50. So it does better with the ground. 5 milliamps better with the ground. Okay. So I would recommend grounding the rig, putting the choke at the transformer with a short counterpoise. One more test. This time the antenna goes to about 10 feet, slopes down, mounted on the fence post, and so we're going to ground it. I got the rig grounded too. I'll ground this transformer and ground the rig, then set our power for 5 watts right there. Check our current. Go out here toward the middle. There we go. 60. Reading 60, which is 180. Whoa. Look at this. 70. All right, that's the center. And of course, it's interesting. It's staying way up there over 50, and we're almost to about 4 feet from the end. I can't reach any further. So we've broadened out the current this way. I'm reading almost 80. This is astounding. What a huge difference. All right, so I can get up to almost 80. Now 80 on our chart. 80 is 240 milliamps. And the most we've gotten so far was 180. Okay. That's just for kicks. Let's see if there's any current on the feed line. No, not enough to even measure. Just maybe 5 or so. That's great. Okay, so this is the way to get the most current in your antenna. I'll tell you that. Ground it to something. It's grounded to a ground rod, a fence, and all kinds of junk. And then that spreads out your current point, and it increases it tremendously. Thanks for watching.